In this lesson, we're going to be talking about how to analyze the graph of f prime. So when we're given the graph of a derivative, we can answer questions about the original function. So for instance, we can determine where a function is increasing or decreasing, or where it's concave up or concave down. We're also able to determine the x values that are extrema or points of inflection. So let's recap some key facts here. If the first derivative is positive, that tells us that f of x is increasing. If the first derivative is negative, that tells us f of x is decreasing. If the second derivative is positive, then f of x is concave up. If the second derivative is negative, then f of x is concave down. A relative or local extrema is where f of x or f prime of x changes sign. So it could be where f of x changes from increasing to decreasing, but also where f prime of x changes from positive to negative, or it could be vice versa of all that, so negative to positive. A maximum occurs when f of x switches from increasing to decreasing. A local max occurs when the derivative switches then from positive to negative. And then we have the reverse. A local minimum occurs when f of x switches from decreasing to increasing, or the derivative switches from negative to positive. If you have trouble remembering those facts, always try and draw it out. So if I draw a graph that has a maximum, for instance, I can see here that it switches from increasing to decreasing, and therefore from a positive derivative to a negative derivative. If I draw a graph that has a minimum, I can clearly see now that it switches from decreasing to increasing, or the derivative changes from negative to positive. And finally, our last recap fact is that a point of inflection is where the second derivative changes sign. So we're going to look at two multi-part questions and answer things about the original function when we're given the graph of the derivative. Okay, so notice here, we are not given f of x on the graph, it's f prime of x. All right, part A says find f double prime of -6. That means find the second derivative at -6. I like to put a little note to myself first. So this is really telling me if we're given f prime of x on the graph, this really means I want the slope, the rate of change. That would be the derivative of the derivative, or the second derivative, at x equals -6. And if I zoom out here and I look at -6, okay, so -6 is here, I can see that the slope is going to be +3. The rise over run is up 3 over 1. For B, find the second derivative at -1. So that tells me I want the slope when x is -1. I can see that it's horizontal there, the line, so that means the slope is 0. C, over what intervals is f of x increasing? Well, let's recap from the first page. What would that mean? If the function is increasing, that would mean that the first derivative is positive. So if I look at where the derivative is positive, that is over the interval -6 to +7. So if I look from those two marks on my x-axis, from -6 to 7, the graph is positive. Part D, over what intervals is f of x concave up? So I know a couple of things about a graph being concave up. I know that the second derivative has to be positive, but that would also mean that the first derivative should be increasing. We want to tie this back somehow to the first derivative, since that's the graph we're given. So again, to kind of recap that, when we think of concavity, we often think of the second derivative. And yes, concave up would mean second derivative is positive. That would also, though, then imply that the first derivative is increasing, and I can see that that's happening on this graph from -9 to -4. And finally for E, at what value or values of x does f of x have a relative minimum? So recall that that means that f of x is changing from decreasing to increasing. Or remember, we want to relate it to the first derivative. The derivative is changing from negative to positive. So if I look right over here at -6, Remember, we're looking at the graph of the derivative, so there it's changing from negative to positive, so that would be my answer. All right, let's take a look at one more. Let f of x be a differentiable function. The graph of f prime of x is shown below. All right, A says, over what intervals is f of x decreasing? So if we tie that with the derivative, that would mean that the derivative has to be negative. So I can see that the derivative is negative from -9 to -2, and then again from -2 to +2. There's two pieces of that graph. You can merge those intervals together, but I'm going to keep them separate here. So I'm going to say f of x is decreasing over -9 to -2 and -2 to +2. And we're going to explain how we know that. And I'm going to say since f prime of x is less than 0. All right, B, on what intervals is f of x concave down? Okay, well, this kind of relates to question 1D above. So we want to tie this to the first derivative. We normally think, okay, concave down would mean second derivative is negative, but that means the first derivative must be decreasing. So if I take a look at my graph here and I go back in with my highlighter, I can see the graph is decreasing from -2 to 0, and then it's decreasing again from 5 to 8. So those are going to be my answers here. So I'm going to say f of x is concave down over -2 to 0 and 5, 8, since f prime of x is decreasing. And finally, for our last question, it says, for what value or values of x does f of x have a point of inflection? So a point of inflection is where the graph changes concavity. So that would mean if I tie this to the first derivative, that would mean the first derivative goes from increasing to decreasing or from decreasing to increasing. So if I take a look at my graph and I take a look at -2, it changes there from increasing to decreasing. At x equals 0, it changes from decreasing to increasing. And at x equals 5, it changes from increasing to decreasing. So let's write that out. So I'm going to write f of x has a point of inflection at x equals -2, x equals 0, and x equals 5. Since f prime of x changes from increasing to decreasing or vice versa. So hopefully this lesson helped you understand a little bit better how we can look at the graph of f prime of x, the derivative, and answer questions about the original function.